All right, we are officially starting the last module for this course. The majority of this module is going to be devoted to exponentials and logarithms. But before we get into that, we're going to look at a couple other topics that deal with combining functions as well as introducing composition of functions. And we're also going to talk about inverse functions. In this section, we're going to review combining functions, and we're going to focus on just our four basic operations. All right, so our four basic operations that we're going to look at in this presentation, we are going to look at addition, subtraction, multiplication, and division. And the main thing that we do want to point out when we talk about algebra of functions is that really we're just talking about a notation. If you have written out f plus g of x, this is basically saying the combined function that is equal to f of x plus g of x. We do the same thing for all the other ones. For instance, subtraction and multiplication. We subtract the functions or we multiply the functions. And division, we divide the functions. The last arithmetic operation that we're going to look at is composition of functions. And I'm not going to get into this right now just because this is going to be the new topic that we will present in the second half of this section. Now, arithmetic of functions does occur in real life. And so just so you know, quite often, a lot of the times that when I do things and I say, why do we do it? Because I can. That's true. But we do actually have real life applications. And so for instance, two examples that you can see is one of them is the profit function. When we talk about calculating profit for businesses, usually what we want to do is we have a revenue function. This represents the money that we are generating, the money that is coming into our company. And from that, we want to subtract the cost function, which is the money going out. And the money that we have left is what we refer to as profit. The second example we have has to do with stopping distance. Stopping distance is equal to the sum of the reaction distance, which is our r of x, and our braking distance, which is our b of x. And so these are two examples of functions that you will see in real-life applications. Okay, now what we're going to do primarily is we're just going to go ahead and work with equations in function notation and just get used to doing these different operations. Now, in terms of simplifying algebraically, we want to talk about, we're going to be using a variety of techniques. So for instance, if we are multiplying, we are probably going to need to implement FOIL, distributing, combining like terms, distributing a negative. All of those things that we talked about in previous sections and in previous courses, we're going to go ahead and implement them here when we talk about simplifying a combination of functions. Now, the other thing that we're going to talk about that we haven't talked about in previous math classes is we do want to talk about the domain of a combination of functions. And so when we talk about addition, subtraction, and multiplication, we just want to make sure that we have the values of x that satisfy both functions. When we talk about the domain for division, we do have an added restriction. We want the domain of the original function, but we also need to keep in mind that when we move something to the denominator, we do have the restriction that that denominator cannot equal 0. And so we are going to have an added restriction. Now in this presentation, we are going to do a couple of different things when we talk about combining functions. We are going to be looking at graphs, tables, and or equations to evaluate functions. We are also going to work with the equations when we talk about simplifying them. All right, so let's go ahead and jump into some examples. We're going to start off relatively easy by working with graphs and tables. So there's a couple different things we can do when we talk about algebra of functions, and it's basically the same things that we talked about previously. One of the first things we want to do is we want to evaluate a combined function. And so for these, it's going to be very similar to what we were doing previously. The only thing is we're going to add in an operation. So for instance, when we look at example A here, we have f plus g of 2. All right, we can go ahead and separate that. And what this is equal to is we want to figure out what is f of 2. And we want to add on g of 2. And if we come over to our graph, remember that when we look at these, the number inside the parentheses is the x-coordinate. And so when we try to figure out, okay, what is f of 2, we are going to be looking at our blue graph. And we are looking for a point that has an x-coordinate of 2. And so we have this point right here. This has the point 2, 4. And on our g graph, when we plug in 2, we are looking at the point 2, negative 2. So remember that the x is the number that we are plugging into the function, that's the 2. And so when we want to evaluate this, what we want is we want the y values. F of 2 is equal to 4, and g of 2 is equal to negative 2. And from here, we simplify. 4 plus negative 2 is 2. And so that's what f plus g of 2 is equal to. All right, let's try a couple more. Let's come to f minus g of 1. And so again, what this is equal to is f of 1 minus g of 1. We're looking for points that have an x-coordinate of 1. And so on our f graph, we have the point 1, 1. On our g graph, we have the point 1, negative 3. And again, for this, 1 is our x value, we want the y values. So we are going to subtract 1 and negative 3. Be very careful here with your signs because what we have is 1 minus negative 3. And this is equal to positive 4. All right, I'm going to go ahead and erase this stuff here so that we can go ahead and not worry about it getting too crowded here. Oh, I should have left the 1 there, though. All right, we'll go ahead, we'll go back to it. All right, so same thing with multiplication and division. You don't want to get so worked up on what does this mean. And so, for instance, if we want to look at the multiplication problem, this is f of 0 times 0. And so we want to find points that have an x-coordinate of 0. On f, I have the point 0, 0. And on the g graph, we have the point 0, negative 4. The 0 inside of our parentheses represents the x values. And so for the y values, we have 0 and negative 4. And these are the numbers that we want to multiply. We get 0 times negative 4, and this is equal to 0. All right, and finally for division, again, don't freak out with the division. We are going to, again, start by rewriting this. This is f of 1 divided by g of 1. And so if we come over here and look at this, I erased them, but remember that we had the point 1, 1, and we had the point 1, negative 3. We want to do the same thing. We want to divide the y-coordinates. And so f of 1 is 1, g of 1 is negative 3, and we can simplify this fraction. That's all we can do, and really the only thing I can do is move my negative up to the top because we don't like the negative on the bottom. And that's it. That's all we're going to do when we are looking at adding, subtracting, multiplying, dividing, when we talk about functions. All right, the next thing we're going to do is we're going to look at tables and see that it's pretty much the same thing. All right, if we come down to this table, we have two functions here. We have our f of x, and we have our g of x. And we're going to do the exact same thing. The numbers inside the parentheses, remember these are x values, so we're going to find the numbers in the x row, and our answers that we're going to plug in are going to be the numbers in the second row. So when we look at this, f plus g of 0, we want f of 0 plus g of 0. All right, f of 0 is, let's see, and g of 0 is equal to 5. We're going to go ahead and add those two numbers together, and we get 7. And we're done. All right, we can do the same thing when we talk about all of our other operations. If we want to look at example B, we want g of 5 minus f of 5. All right. We want to plug 5 into the g equation. Notice this is backwards. And so here, g of 5 is equal to 8. F of 5 is equal to 10. And so we're going to go 8 minus 10, and we get negative 2. All right, for C, we do want to go ahead and plug in and multiply. And so here what we have is we have g of negative 5 times f of negative 5. And so when we plug this in, we have g of negative 5 is going to be the negative 10. And f of negative 5 is going to be 3. If we multiply these two numbers, we get negative 30. All right, and last one, we have f divided by g of 5. And so again, remember that what this means is I just want f of 5 divided by g of 5. And so f of 5, we get 10. G of 5, we get 8. And all we can do with this is simplify our function, or simplify the fraction. And so here, this is our it's not letting me do it. Okay. We're going to go f of 5 divided by the g of 5. And when we simplify this, we get this is equal to 5 over 4. All right, so that's kind of the easy thing that we can do is the evaluate, okay? And so evaluate is just for each x value, we want to plug it into both of our equations or look at both of our graphs or both of our tables and find the y values. And then go ahead and add, subtract, multiply, divide, depending on what operation we have inside the first set of parentheses. All right, so now the next thing that we're going to do is we are going to go ahead and work with equations. And what we want to really focus on is simplifying the function and identifying domain and range. Sorry, domain. We're just going to do domain. Okay, so if we look at both of these functions, f and g, we're going to start by finding the domain. So for f of x, our domain, we are not allowed to have negatives inside a square root. Note that my square root does end after the x, and so what we have here is x has to be greater than or equal to 0. G of x, we have the same restriction, and so because it's also just a square root, we don't really care about the outside. We also have the restriction, x has to be greater than or equal to 0. All right, so now we're going to go ahead and do some math. So we want to figure out what is f plus g of x. And so what we have here is f of x plus g of x. And wherever we see our f of x, we're going to plug in the square root of x minus 1. And so that's what we have here, square root of x minus 1. Wherever we see g of x, we are going to plug in square root of x plus 1. And what we want to do is we want to simplify this by, when we add, all we can do is combine like terms. And so what we have here is my negative 1s and my positive 1 cancel out. And when we add square root of x and square root of x, all we get is 2 square root of x. Now when we do addition, we just have to keep in mind the domain restrictions for both of these and what's going to satisfy the entire function. For here, because we have the same domain for both f and g, we don't have any issues here. And so we are going to have that our domain is x is greater than or equal to 0. All right, let's try f minus g. So remember that this is going to equal f of x minus g of x. And so again, wherever we see f of x, we're going to plug in f of x. And wherever we see g of x, we're going to plug in g of x. And so when we do this, we get the square root of x minus 1 minus the square root of x plus 1. And we do want to make sure that we are subtracting the entire function. And if you want, you can put parentheses around both of these, always just to make sure that you know exactly what we're working with here. All right, we do want to distribute our negative. We do have to remember that when we are subtracting. And if we distribute the negative, we get the square root of x minus 1 minus the square root of x minus 1. And what we get here is we do get that our square root of x's cancel, and we are left with negative 2. But we do have to be careful. We do still have a domain restriction. We do still have that x cannot be greater than or equal to 0. If we type in, similar to when we talked about the wholes the other day, when we plug in the original function, not the simplified function, but when we plug in the original function, and if you go to your table and try to check it, it's going to tell you that there's an error whenever x is less than 0. And so we do still have the same domain restrictions when we subtract as we do with the original functions. All right, let's look at a couple more. All right, we have f times g of x. And so for this, remember that we just want to multiply our functions. We have the square root of x minus 1 times the square root of x plus 1. And we want to simplify, so we're going to FOIL. If we multiply square root of x times square root of x, well, we get the square root of x squared, which is just x. If we go ahead and multiply again, our outsides, we get plus the square root of x. Insides, we get minus the square root of x. And last, we get minus 1. All right, if we simplify this, we get x. My square root of x's cancel, and I get minus 1. However, again, remember that we do still have domain restrictions. We cannot plug in negative numbers and have answers. We can't add error plus error and get something. And so we do still have a domain restriction for this. And it is still x has to be greater than or equal to 0. All right, finally, the last one, we want f divided by g of x. And as much as you guys hate dividing, this is actually the easiest one that we have here. If we plug in f of x, we get the square root of x minus 1 over the square root of x plus 1. And you really can't do anything else with it. And so we're done. This one, we do need to be careful with our domain because we do have the requirement that x cannot equal 0. Or sorry, x has to be greater than or equal to 0. But we also have an additional requirement that the denominator cannot equal 0. And so for instance, here, we actually don't run into any problems. If we set this denominator equal to 0 and try to solve it, what we get is the square root of x equals -1, but square root cannot equal a negative number, and so we don't have any issues. All right? On the other hand, what happens if I flip it around? If we have g over f of x, what this is equal to is the square root of x plus 1 over the square root of x minus 1. In this one, we do have some problems. We do still have our domain. We have x is greater than or equal to 0. But if we check our denominator and try to set this equal to 0, what we get is the square root of x equals 1. And that is a possibility. If we square it, both sides, we do get x equals 1. And so if x is equal to 1, then we have a denominator that is that's 0, and that's not allowed. In order to write this in interval notation, so for instance, if we're in set notation, we just say x is greater than 0 and x is not equal to 1. In interval notation, what we are going to do with this one is we are going to start at 0. We're going to go to 1, but remember we can't equal 1. We're going to take a tiny step over 1 and then continue on to positive infinity. I don't know if I have any of those problems in the homework, but just in case they do show up, you'll know what needs to be done in that case. All right, this takes care of the first 4 operations we have when we talk about combining functions. Then the next one, we're going to talk about composition of functions. All right, take a break, and I'll see you again soon.